Okay, let's talk more about the anterior-posterior ground reaction force during running. Okay. Now, the trick with this setup is we need to think the horizontal direction only. And our eye is usually drawn towards the vertical movement during running. But we're going to have to really focus on what's happening in the horizontal direction only. And horizontal meaning anterior posterior. I'm not looking at medial lateral at this stage. And what we're going to do is look at the position, velocity, acceleration, and the ground reaction force in the AP direction, anterior posterior direction. And again, the challenge is we need to think horizontally, not vertically. So we're not dealing with gravity. Gravity is a vertical force. We're only dealing with the horizontal component of the ground reaction force. And the funny thing is, if that component is sometimes that force is positive and sometimes it's negative. And this PVA Grf exercise helps explain why that is. All right, so let's go through this. I'm actually not going to start here with position other than to say, here's ground contact, here's toe off or takeoff. Here's the location of the center mass horizontally at ground contact. So we've got to think this is the horizontal position. So this is moving forward in this direction, or when we're going upwards in here. So if we're running and we're tracking the center mass, our center mass will move forward over time. It will never go backwards. It will never go back towards zero. So we're only concerning ourselves with running forward. So here's my ground contact position here. At takeoff, I'm going to be somewhere else forward, more forward, further from the origin in the horizontal direction. Okay, so horizontal direction only. I start here and I run to this point at this moment in time. This is time on the x-axis. All right, I'm not going to fill those dots in just yet. All right, let me see here. Yeah, okay. All right, so let's look at velocity. Velocity is probably a little easier to start with. We're only going to be running forward, so we're only going to have positive velocities. We're never going to have negative velocities when we're running. A negative velocity would mean we'd be running backwards. So all our velocities will be positive. And at the moment of ground contact, let me draw that line down here and toe off. At the moment of ground contact, we have some positive velocity. Some positive velocity. Because we're moving forward at the moment that the foot strikes the ground. And if we're trying to run the same velocity, we're trying to run a constant velocity, then that means at takeoff, at toe off, we're going to have the same velocity. So what happens in between? Well, what happens when we strike the ground is we actually slow down. I'm going to exaggerate it here so for the purpose of this, and then speed up. We slow down and speed up with each foot strike. And you're going to see how this all gets tied together. So what happens after takeoff? Well, the person's off into the air and they're a projectile until the next foot strikes the ground. But there's a period of time where the person is a projectile. What horizontal forces are acting on the projectile during flight? The answer is none, as long as we're not dealing with air resistance. Gravity is a vertical force. So if there's no horizontal forces acting on the runner during flight phase, that means velocity will be constant, acceleration will be zero. So velocity will be constant in flight, and it'll be constant in flight on this end too. So this is flight. And this whole period is stance, where the foot is in contact with the ground. Okay, and so flight over here as well. All right, so now let's go down to acceleration. Drop that dotted line down here that indicates that minimum velocity. Again, still positive though, because we're running forwards. We're never stopping. We're running forwards the entire time. These slopes are all negative, therefore acceleration will be negative. These slopes are all positive, therefore all these accelerations will be positive. Acceleration will be 0 here because velocity is constant. Acceleration will be 0 here because velocity will be constant. So now I've got a period of 0 acceleration, 0 acceleration, negative, and positive. And my acceleration profile is going to look like that. Now, maybe you already watched the ground reaction force profile for the anterior posterior direction video, or maybe you'll watch that one after this. Either way is fine. But now I have periods of negative acceleration and positive acceleration. What does this negative acceleration mean? Well, we go up here to velocity. This is moving forward and slowing down. Velocities are getting less while moving in the positive direction. What's happening over here? We're moving forward and we're speeding up. Velocities are getting greater as we go further in time. So we're slowing down and we're speeding up. We're slowing down in this region and we're speeding up in this region. Well, you should have done the kinetic analysis video at this point, but if we take our forces acting on the object, we know we get mass times acceleration of the object, and now we're only dealing with the anterior posterior direction, and the only force we're dealing with in the anterior posterior direction is the ground reaction force in the AP direction. That equals MACOM. So the ground reaction force profile, we can figure that out by multiplying mass and the acceleration at any moment in time. So if acceleration is negative, the ground reaction force is going to be negative. If acceleration is positive, ground reaction force will be positive. If acceleration is small, this is going to be small. This is mass is a constant. So ground reaction force and acceleration will be directly linked. And our ground reaction force profile will look just like our acceleration profile that we've drawn. So I'm trying to draw those parallel to each other. And we do have negative force and we do have positive forces in the AP direction. Magnitude is not that big. Okay, it does depend on some running style, surfaces that we run on, things like that. But if we're trying to run a constant velocity, this is a pretty typical anterior posterior ground reaction force profile. What is this negative force doing? It's causing the negative acceleration. What's the negative acceleration doing or representing? It's representing forward movement, slowing down. What's the positive force causing? It's causing a positive acceleration. What's the positive acceleration mean? It means in this setup, forward movement and speeding up. Okay. So these are all linked mathematically, and if you watch the other video, we can start looking at how much braking there is, how much propulsion there is, which is going to tell us how much slowing down there is and how much speeding up there is. And if I wanted to connect the dots up here, I would actually have a graph that would look like a straight line right here, and then I would have a sort of an S-shape curve and then a straight line here. That slope and that slope would be the same if I'm running the same velocity at ground contact and toe off. This shape drives this shape. The shape of this curve drives the acceleration profile, which yields the ground reaction force. Now, what we really should be saying is the ground reaction force causes acceleration, and that acceleration is reflected by rate of change in velocity, which is reflected in the position versus time plot. So it's all linked mathematically. All right, but that is the PVA ground reaction force set up for anterior posterior ground reaction force.